Well, and perhaps this is a beautiful segue into our next segment of the program where we talk about technology. Technology has changed our lives in so many ways, and new tools are at the ready for weather prediction and interpretation. So let's take a look at a quick tape.
With the advent of the internet and sites such as weather.com, many people are taking a more active role in exploring the weather that surrounds them. We are becoming experts at predicting the weather, or at least we think we are. Where does that leave the local weather meteorologist? New technology is developing more creative ways of describing and predicting what is coming our way. What are the limits, and what can we still learn about the weather through projects such as Vortex 2?
Well, weather.com is one of my favorite sites. I check it in the morning and what's my day going to be like, and sometimes it's accurate and sometimes it's not. Now, you have many years of history as a weatherman. I'm going to start with you, Craig, and tell us a little bit about what you think of sites like weather.com or resources that individuals turn to instead of perhaps flipping on the TV.
I think they're great. I mean, I think people have to realize, you know, what their limitations are. I mean, and of course, weather.com. There's also weather.gov, which is National Weather Service. I really like that one. So, but they're both fine. The data or the forecast, for the most part, originate with the National Weather Service, and so any of those sites provide a wealth of information. I mean, it used to be you had to watch TV to maybe see a radar image or something like that. To me, it's just fantastic that we can sit down at a computer at our home and we can look at satellite imagery and radar and current weather forecasts, and all those tools are on there. Mm-hmm. Now, you got to be careful. You don't want to be the person saying, okay, I can predict a tornado or something because I can see a radar on the screen. You have to understand it. So the other side of this is that people need to understand what they're looking at. And so the plus is it's there. The minus is, you know, how do I use that?
Mm-hmm. You were mentioning, Steve, too, about on-the-ground personnel. Are they still necessary? And it sounds like maybe there's a shortage of some of those folks.
Yes, on-the-ground people are very important. Don mentioned we are deploying some electronic networks out there, but we still rely on, like, for instance, we use the radar. We see people might see it as saying, oh, it's just raining there, or that's where they're saying there's a tornado or a hail or something. But as a hydrologist, we use the radar to quantify how much precipitation fell, and it's those ground observers that are out there that tell us, okay, in the last 24 hours we had 3 inches of rain. What does the radar say there? And the radar, you know, may plus or minus a little bit. Well, then we can have confidence to translate that the radar's quantifying it accurately where we don't get a ground report, and that's invaluable in hydrology to be able to have confidence of how much water fell in the landscape. So we rely on the ground reporters there, and also in severe weather. There's severe weather spotters. Very essential to go out and actually look for actual verification that a funnel cloud is forming. The radar can throw you off. Even the professional trained meteorologist can be thrown off on a tornado signature for some other reason, and so it's important to have someone out there spotting.
I agree. There's always going to be a role for eyes on the ground with spotting for tornadoes. And when you mentioned, Steve, verification of radar, Minnesota's blessed with having 1,500 volunteer rain gauge readers out there in the state. So in some counties we have so many gauges we wonder if the rain actually reaches the ground sometimes. But those gauges are really handy for verification, especially when flash floods can be very localized. There's a big difference between getting almost 7 inches of rain and 4 inches of rain in a model. So if we can relay that information to the Weather Service, that definitely helps them out.
And you know that's a good point. Is that you need this verification on the ground, because all those tools have their strengths. You know, radar sees certain things. There's things it doesn't see. Same with satellite imagery. You know, all the remote sensing. You know, there's things they see and things they don't see. So you still need the eyes and ears and, you know, the people to measure things on the ground.
You know, that's a great point. This morning was a perfect example. I checked my weather. We had an on-location shoot outside. I looked, there was no green on the map anywhere. And I got to the gas station, was filling my car, and it's a heavy drizzle. Why is it? Let's talk about the limitations of why can't you, whatever satellite, or why can't they see that rain?
Well, radar, the smaller the drop size, the harder, because it's a certain wavelength of radiation that's going out, and it's being reflected off of something out there, and it's the weather radar is actually tuned to spot a certain size of hydrometeor, And so when it gets so small, it just does not get enough energy back. So it's the energy back that is actually what you see depicted on the television. When you see the different colors in that, that's actually a reflection. It's a quantification of how much energy came back, and so the more energy come back, the larger drop it hit.
Okay.
So a heavy drizzle, it's not going to see that.
And a radar beam doesn't hug the ground.
Yeah.
Right.
I mean, the farther you are away from the radar, the higher up the beam is.
Yeah.
So it's seeing things progressively higher and higher. So that's the other side of it too.
Interesting. Weather prediction is a challenge, and I know often, folks sit in their armchairs and say, "Oh, I could have done a better job than that." Talk about what tool you would love to have in your toolbox that you don't currently have, and what would it tell you about the weather that's important to the work that you do?
I want the Star Trek, like they had in one of the movies, the climate or weather amelioration system. Get rid of this.
There you go. One thing I remember in going through college was I wish there was a more denser upper air network, because your computer models are all, no matter how fast you get, no matter how much whiz-bang computer technology you get, they're all going to be limited by the data you put in there. And if you only have 2 upper air balloon launches per state, that's the best you're going to get in the upper level. Now there's other tools out there, I'm a little removed from it, but I remember on the wish list, if you could wish anything in the sky, it would be more upper air observations, maybe more frequently. I know sometimes, Steve, they do launch a special one if there's severe weather.
Yeah, severe weather, they'll launch extra one, but that's a very, very labor-intensive thing to monitor the kind of the lower part of the atmosphere. Satellites do good; they see the top of the atmosphere, but most of the action is in the lowest half of the atmosphere, which really, I don't mean physical half, I mean half of the mass, and that's up I think about 20,000 feet or something is the first half. And so we need to monitor that with balloons that carry an instrument up that measures the humidity and the temperature, and then to calculate the wind speed by tracking it. And it's a fairly expensive proposition, on the order of about $100 per launch. So.
So when you see these sweeps of this low fronts coming through or this high pressures coming through, and here you watch those predictions on whether it's your local news channel or weather.com, how do you guys make those predictions?
Well, if you're watching television, almost all of those are straight out of a computer model. And so the person on the air would be picking which one to use. And so that would show you how a computer was forecasting storms to move. Now, the Weather Service might change their forecast and maybe not follow a model exactly. Talk about that.
The biggest change would be in the first 24 hours. is you're actually tracking the physical weather, like timing a front coming down from the Dakotas, or like an Alberta clipper in the winter. The experience tells you whether the computer models can accurately depict that or not. And so that first 24 hours, maybe 2 days, you're tuning it a little more based on experience. You get out past that, 3 to 5 to 7 days, a lot of that very computer driven. But in relaying a lot of information to the public, Elwin is one of the greatest resources. Being an extension climatologist, he contacts probably personally the most people in any given state. He does. And that's what really that's the education aspect. That's that outreach education that's so important, is that we're at the Weather Service and we're in Chanhassen, Minnesota, and our ability to directly impact people, face to face, is very limited. But we rely on Elwin and Mark Seeley here in Minnesota to really take it to the people. And maybe Elwin could talk about that, about how that works, of bringing it out to the people.
This whole discussion is so delightful to me. I spent my first 3 years working with weather with the upper atmosphere, right, where you would like to have more information. I spent my next 6 years with the National Weather Service. And the thing I learned in the National Weather Service was not to trust the models. I used to give papers in Washington with Dr. Klein sitting there, the fellow in charge of the model. And I remember in the time I talked about, we have a Moss forecast to cover up the total failure of the numerical models. And everyone gasped, except Dr. Klein, who was responsible for it. Well, we have these things developing. But still, in the morning, I would sit down and I'd look at the weather map of what had happened. And I would take my blank piece of paper that showed a map of the area I was interested in, and I'd draw for 12 hours, I'd draw one for 24 hours, I'd draw one for 36 hours, and then I would look at the model. And when they disagreed with my piece of paper, I looked for where I'd made my mistake. And I'd usually find it. And sometimes I wouldn't. And when I couldn't find what I'd done wrong and why the model disagreed, I went with me. I made it for a full year without a wrong forecast. We try to teach that to our students.
Yeah.
But we have to remember, weather is not a totally random thing. It's physics. It's physics of the atmosphere, and it obeys the laws of physics. And so this is the important thing for us to remember, that we are going with an absolute science, even though we do not have absolute forecasts. We have a lot of approximations that go in them. We were talking a few minutes ago about the models for the long-term prediction. We call them the global circulation models, or GCMs. They're based on 5 variables.
When you get right down to it.
And 5 variables do not cover well the decadal effects that were mentioned earlier this evening. And so they can't be in there. And it's drawn some people that are new to climate science, although they're well trained and they're brilliant people, they're still new to climate science. They weren't trained as climatologists. They come into it because of their expertise in adjacent things. And they will say, look, the carbon dioxide is now the big forcing element of the 5. I'll bet these other 4 don't make any difference anymore, like the change in the brightness of the sun. But they will still make a difference. Why, it's become almost like having CSI. Only now we're going to call this climate scene investigation.
And there's a lot to investigate. There's no doubt about that.
This is a whole new career field to determine if the climate effect in our local area is indeed due to a global scale change, or if it is just the natural variation that we get in this world that takes place over a year, or 5 years, or 10 years, or 30 years. And the 10 to 30 years of the things we talk about is the decadal scale variability.
Are there any holes in the information that you wish you had? You talked about upper atmosphere information. There's a Vortex 2 project that's doing a scientific study on more severe weather and tornadoes. Is there a gap in the information or a study that's taking place that you know of that you're really looking forward to seeing the results?
I don't know if there's a study going on, but I think one place, certainly from a long-term climate perspective, is our understanding of oceans. Anything going on over the oceans or within the oceans, we have a very difficult time with getting information because, as Steve was talking about, most people don't live in the ocean. There are a few island places, but there's not a lot of on-the-ground information from ocean sites. And that also includes the southern hemisphere, which is mostly ocean and which is not highly populated. So if you looked at where our observations are, they come from places where people live. That makes sense. But if we're trying to look at sort of global scale climate, which I'm not always sure we should be looking at global scale. We should be looking at, what's happening in Iowa, what's happening in Minnesota, what's happening in the upper Midwest. But all of these things fit together. But oceans, it turns out, have a big impact on the climate, on the weather that comes our way. What kind of front are we going to have? Is it going to be wet or is it going to be dry, and that sort of thing. So that's one place where I think it would be great to have on the ground, so to speak, information, but we're just never going to get it.
I'll go ahead, Don.
No.
Go. I've been talking more than you.
I was going to take us another direction. Stephanie asked, where are the holes? What are we missing? And I actually have an expertise in snow in mountains and snow water equivalents and snow water supply. And there's a hole in the research or in our understanding in mountains are water towers for much of the globe. Now, we don't have mountains here in Minnesota or in Iowa, but we do rely on snowmelt to an extent. The people who manage dams, not dam managers, but who manage dams and water supplies, it's very important for them to understand not only how much water is in the snow, but when will it melt? When will it be coming down the river, down the pipe, so to speak? And something that is changing is the amount of particulate matter in the atmosphere, dust. Understanding how much dust is landing on snow when. So when is snow going to start melting? And what we've been seeing in the last few years is managers of dams have been having an extremely difficult time because snow is melting a little earlier in the season. And so there are now some studies going on about dust on snow. It sounds trivial, but this is huge in understanding this. And so you asked that. That, for me, in the areas where I work, this is critical to understand this and to identify these networks and helping managers of dams, which of course is water supply for drinking, water supply for agriculture, and flood protection on down the way. Very important to understand this bit of research. Yeah.
Craig?
If I really, something I would really love to see would be a computer model that forecasts the formation of individual thunderstorms.
Oh yeah, that would be awesome.
And circulations within it and where tornadoes would occur. We can't do that right now. We look at broader scales and then essentially surmise areas where this would occur. Until you see it form, you don't really know you have it. But I think it'd be just great to be able to have running a model that says at 2 o'clock this afternoon a thunderstorm will form over Austin, and then it'll move to Rochester, in this amount of time. But we're probably not close to that yet, are we?
We're not quite there. I mean, there are some. We talk about when we're looking at climate change, we're talking global, and maybe we need to get down local. They do run some fairly localized models that do try to make a prediction of what the radar will look like at a certain time, and and they do okay, but it's not down to that scale of a town. It may say, thunderstorms erupt. You could see the thunderstorms coming over southern Minnesota, but it may be on the order of Mankato versus Austin. So it's 100 miles off. So it's not to that level of predictability where you can say cancel the picnic. That's not there yet.